Okay, we're going to go through the starter question now, and we will begin our lesson. So welcome everyone to our GCSE Maths session. In today's lesson, we are going to be looking at functions. Now, Year 11s who are sitting your GCSEs currently, functions hasn't been on the paper yet, on paper one, so it's likely to come over the next two papers. That's why we're going to look at it in today's lesson. And we're also going to be finishing off by looking at transforming graphs, which is also something which hasn't come up in paper one. In paper one, there was a bit of graph work, there was a bit of trigonometry graph work on that Excel paper, but we didn't see any transforming graphs with functions. So we'll see that at the end of today's lesson as well. Okay, so we're going to start off simple with normal functions, and then we'll go into graphical functions, and then we will end off with a look at as normal. If you guys have any questions at any point, you can let me know in the Q&A. I'll be more than happy to answer them for you. Okay, so we're going to start off by looking at the starter question. So in our last lesson, we looked at compound interest, and this was the last question that we had a look at in our last lesson. So if you guys don't have access to the Q&A as well, I know some of you don't have access to the Q&A, there's a QR code which you can scan over here at the bottom. And if you scan that QR code, you can let me know your questions via a form. Okay, so going through this question, so this is a compound interest question. It says Matt wants to invest £8,000 for 3 years. He can choose between Bank A and Bank B. So we can see Bank A, 1.2% compound interest per annum, and Bank B, 2% compound interest for the first year, and 1% of compound interest for each year after. So it's 3 years. So that means each year after, this is going to be for 2 years. It's going to be running for 2 years. And compound interest hasn't been on the paper yet as well. So it's a hot topic which can come up in either paper 2 or paper 3. Okay, so let's look at Bank A first. When we look at Bank A, we can see that it's compound interest. So we're starting off with 8,000. So we're going to have 8,000 as our total amount. We're going to open brackets. We're going to put 1. And then it's 1.2% compound interest. So because it's 1.2% compound interest, we're going to add. Remember, we only subtract when it says depreciates. And then we're going to put 1.2 divided by 100. And it's going to be to the power of years. And it's for 3 years. So it's going to be to the power of 3. So when we type that into our calculator, we have 8,000, 1 plus 1.2 divided by 100 to the power of 3. That gets you an answer of 8291.47. And then let's have a look at Bank B. When we have a look at Bank B, it's 2% compound interest for the first year, and then it's 1% compound interest for each year after. So if we have a look, so we're starting off with £8,000, and then we have 1 is 2% for the first year, so we're going to have add 2 over 100 to the power of 1 because it's only for 1 year. We're going to type this into our calculator. So it's only for 1 year, and it's 2%. And that's going to get you 8,160. And then it's 8,160. For the remaining 2 years, it's at 1% compound interest. So it's going to be 1 plus 1 over 100 to the power of 2. So 1 over 100 to the power of 2. And we get an answer of 8324.02. Okay, so as you can see, these are our two values. When we compare these two values, which one gives us the most money? We can see Bank B gives us the most money. So that means our answer is going to be Bank B. Okay. So moving on, so we've had a question, can this question come up in a non-calculator paper? Most likely this will not come up in a non-calculator paper, just because it's better to have a calculator. But saying that, one of the most common calculator topics, iteration, came up in a non-calculator paper, the paper one that was done this year. So I wouldn't expect this topic to come up on a non-calculator paper because most of the time you need a calculator to do questions like this. Okay, but this is just a recap. We're not going to be sort of focusing on this in terms of today's lesson. This is what we did in our last lesson. What we're going to be looking at today is questions like these. Okay, so these are functions. And functions are basically represented like this. F of x equals x minus 4. The F over here stands for function, and whatever's inside the bracket shows you the input. So what this is saying is the function, f for function, so the function of x, because x is inside the bracket, is equal to x minus 4. Okay, now when we have a look at this first example, it says f of 5, which means the function of 5. Now, as you can see, originally we had an x inside the bracket, and so we had x minus 4. But now what we're doing is we're changing that x into a 5. So because we're changing that x into a 5, we know that f of x equals x minus 4, but now we've got f of 5. So we're going to change the x into a 5. Everywhere there's an x, we're going to change it into a 5. So as you can see, we have an x here to start off with, so we're going to change that into a 5 because we've changed what the input is. The input is whatever's inside the bracket. So we're going to change that x into a 5, and it's going to be 5 minus 4. And 5 minus 4 gives you 1. So the answer to this question is just going to be 1. Okay, so I want you guys just to quickly have a go at this one, the next one, f of 3. Okay, what's that going to give you? Just 30 seconds. We're starting off simple, and then we're going to build up on difficulty. So what's pod B going to be? Type your answer into the Q&A once you've got an answer. I'll just give it 10 more seconds, and then I'll start going through the answers. Okay, so we've got f of 3 this time. So we know that the function of x, that's what f of x is, the function of x, we know it's equal to x minus 4. Now we've got f of 3. Okay, so f of 3 means the function of 3. As you can see, the x has changed into a 3. So over here, what we have after the equal sign, we're going to change the x into a 3 as well. So 3 minus 4, and 3 minus 4 gives you an answer of minus 1. So the answer here is just going to be minus 1. Okay. So this is normally for, it's not normally for IGCSE. It's for sort of normal GCSE. It's covered across all the exam boards for GCSE. Okay. Now, the next question, the first two are very similar to the ones that we've had a go at. So I'd like you guys to have a go at the first two examples, and then I'll start going through the answers. I'll go through the third one. If you feel confident enough to have a go at the third one, feel free to have a go at the third one. But have a go at the first two and type your answers into the Q&A. Okay, so now you've got g of x equals 2x squared minus 10, and then you need to work out what g of 2 is and what g of minus 2 is. Okay, just 10 more seconds and then I'll start going through the answers. So it's the same concept as before. Okay, so if I start going through the answers, so it says over here, we know that g of x equals 2x squared minus 10. That's what the function of g is. So when g of x equals 2x squared minus 10, we need to work out what g of 2 is. So as you can see, we are changing what the input is. So the input is what goes inside the bracket. And as you can see, the input is x. But over here, we're changing what the input is. The input is now 2. So what we're going to do, everywhere we have an x, we're going to change that x into a 2 because we've changed what the input is. So that's going to be equal to 2. We've come across an x. So instead of x, we're going to write down a 2 because that's what we have here. 2. And then we have the squared, and then it's minus 10. Okay. Now, bid maths, remember, indices goes before multiplication. So we're going to do 2 squared first. 2 squared is 4. 4 times 2 is 8. And then 8 minus 10 is going to get you minus 2. Okay, so 2 squared is 4, and then 4 times 2 is 8, and then 8 minus 10 is going to get you minus 2. So the answer for the first one is minus 2. Okay, now for the second part, we've got g of x. Again, it's equal to 2x squared minus 10. That's what g of x is equal to. And then the input is now minus 2. Now, because the input is minus 2, we're going to change what we're going to put inside the brackets. So we've got here a g of minus 2. So wherever there's an x, we're going to put a minus 2 instead. So we've got 2. X is replaced with minus 2. So we're going to add a minus 2 there. We're going to square it, and then we're going to subtract 10. Okay, now minus 2 squared, again, bid mass, minus 2 squared. Minus 2 times minus 2 gives you positive 4. So then we have 4 multiplied by 2. 4 times 2 is 8. And then 8 minus 10 is also minus 2. So the answer for this one is also going to be minus 2. And the reason why that is the case is because when you square a negative number, you will get a positive. Okay, so squaring a negative gives you a positive. Okay. Now moving on, it says solve g of x equals 8. Okay, so this time we need to solve g of x equals 8. So when we look, what is g of x? We know that g of x is the same as this thing that we have over here. G of x is the same as 2x squared minus 10. That's what g of x is. Okay, we can see that in the question. The question has told us that g of x is 2x squared minus 10. So that means that 2x squared minus 10 is equal to 8. We're just going to replace the g of x with 2x squared minus 10 because both of them are equal to the same thing. 2x squared minus 10 is g of x, and g of x is equal to 2x squared minus 10. So when we're solving it, we're just going to replace the g of x with the alternative. We know that it's also equal to this 2x squared minus 10. So instead of writing g of x, we're going to say 2x squared minus 10, and we're going to make it equal to 8. Okay, now what we're going to do is we're going to rearrange this to get x the subject. So at the moment, the 2x squared is being subtracted 10. So 10 is being subtracted from it. So let's move this annoying 10 to the other side. So if it's being subtracted, to get rid of it and move it to the other side, we're going to add 10. We're going to do the opposite, and we're going to do the same to both sides. So we're going to add 10 to this side as well. Okay, and that's going to get rid of this minus 10. So now we're left with just 2x squared on this side, and that's equal to 8 add 10. 8 add 10 gives you 18. Now, to get x by itself, at the moment it's being multiplied by this 2. We need to get rid of the 2. It's being multiplied by 2. So to get rid of it, we're going to divide by 2. Whatever we do to one side, we do the same to the other side. So we're going to divide both sides by 2, and that's going to get rid of this 2. Okay, so we're going to be left with x squared on that side, and that's equal to 18 divided by 2, which is 9. And then we just want x. At the moment, it's being squared. So to get rid of that squared, we're going to square root the other side. So we're going to have x equals the square root of 9. Now the square root of 9 is just 3, so x is equal to 3. Okay, so when it says solve, you want a value for x. So x is going to be equal to 3. Okay, so that's how you solve expressions. When you've got g of x, you're just going to swap it for what g of x is actually equal to. So we're given in the question that g of x is equal to 2x squared minus 10. Okay, so moving on to the next question. We've got some new styles of questions, and this is composite and inverse functions that we're going to go through. So will everything you cover in this lesson also be for foundation? It won't also be for foundation. This will be sort of a higher topic. It's not specifically for foundation. That's why we split the lesson. So this week, what we're doing is higher only. Next week, what we'll do will be suitable for foundation. Okay, so it says over here, given that f of x equals 2x minus 4 and g of x equals 3x plus 5, it says find gf of 3. Now, this is what you call a composite function. Okay, so this is called a composite function. And on this year's paper, hasn't been on yet, it is likely to come up on the next two papers. GF of 3. Now, what does this mean? When we talk about GF of 3, what does this mean? It means the G function of the F function of 3. And it's not as hard as it looks. All you're going to do is you're going to start off with the right. Okay, so start from right and work to the left. So the letter which is closest to the number, we have a 3 over here. The letter which is closest to it is f. So we're going to get the f function, and we know that it's f of x equals 2x minus 4. That's what the f function shows us. Now we want f of 3. So instead of x, we're going to put in a 3 instead of x, just there. So everywhere we see an x, we're going to replace it with a 3. So we're going to have 2, 3, minus 4. Now 2 times 3 is 6, and then 6 minus 4 gives you 2. So that means this part of the expression we've worked out, f of 3 is 2. But now we still need to deal with this g part of the function. Okay, and the g formula is over here. G of x equals 3x plus 5. So g of x equals 3x plus 5. Okay, now the answer that we've just worked out is 2. So what we're going to do is in place of x, we're going to write down a 2. So we're going to have g of 2, and that's going to be equal to 3x plus 5. So everywhere there's an x, we've changed the input. It was x originally, now it's 2. So everywhere we see an x, we're going to replace it with a 2. So it's going to be 3, 2 plus 5. 3 times 2 is 6, and then 6 plus 5 equals 11. So that means the answer to this question is going to be 11. Okay? And that's what you see in a composite function. With a composite function, you basically have two letters that are joined together. You always work from right to left. So the letter which is closest to the bracket or closest to the number, you start off with that function. Because the f was closest, we started off with the f function. And then what we did, we got an answer for the f function, which is 2. We then moved to the left. The next letter was g, so we substituted it into the g function. And that's how we got our final answer of 11. Now, the second part we will come back to. I want you guys to have a go at these first two parts. Well, we'll have a go at this first question first, and then we'll have a go at the second one. So it says find fg of x. Okay, so it's the same concept. I'd like you guys to have a go at it. I'll give you guys a couple of minutes and then type your answer into the Q&A, and then I'll start going through the answers in a couple of minutes. Yes, I can go back just for a minute. Yeah. Okay, I'm going to move on now. So we're having a go at that first question there. Okay, just 30 more seconds, and then I'll start going through the answers. Okay, so I'm going to start going through that first question that we had. So it said, given that f of x equals 3x plus 1 and g of x equals x squared, it says find fg of x. So when we're working it out, we're going to start off with the letter which is closest to the brackets. So closest to the brackets, we have g. So we're going to start off with g of x. And as you can see, there's no number input. It's just the letter. So we're going to leave it as the letter. So we have g of x. G of x, and that's equal to x squared. Now, we don't need to do anything to this because this is just g of x. Okay, we've got g of x already, and that's what I want. So we've worked out this part, g of x, because that's given in the question, g of x. We're now going to substitute the answer. Because we've worked it out, we now need to move on to the f function. So our answer is x squared. We now need to substitute that into our f function. Okay, so we have f of x equals 3x plus 1, but the answer that we've just received is x squared. Okay, because the answer we've just received is x squared from the g of x function, we know that's going to be our input. The input is x squared this time, and we're going to replace the x with an x squared. So we're going to have 3, and then the x is going to be replaced with an x squared instead, and then plus 1. So our final answer for this question is going to be 3x squared plus 1. Okay, so I'd like you guys to have a go at this next one as well. Work out the expression for g f of x. So we're switching the letters around. So it will make a difference to your answer that you get as well. So have a go at it. I'll give you guys a couple of minutes, and then I'll start going through the answers. Okay, just one more minute, and then I'll start going through the answers. Okay, so I'm going to start going through the answers now. So it says work out an expression for g f of x. Now, when we're working out the expression for g f of x, let's have a think about it. We're still going to follow the same steps. So we're going to go from right to left. So we've got f of x this time, and f of x is 3x plus 1. So f of x equals 3x plus 1. We're going to start off with the right, and because there is no input, we can leave our answer like that, 3x plus 1. And then we've dealt with this part of the expression. We're now going to move on to the g, because we're moving from right to left. Now we know the g function, g of x equals x squared. So g of x equals x squared. Now we know the input is different. The input is 3x plus 1, because we're going to input our answer that we've got from our f of x into that expression. So what we're going to do, our answer that we received from the f of x was 3x plus 1. So this time the input is going to be g of 3x plus 1. And in place of x, we're going to add in this 3x plus 1. So we're going to have 3x plus 1 in place of x, and all of that is being squared. So if we expand the brackets there of 3x plus 1, 3x plus 1, expanding the brackets, we get 9x squared plus 6x plus 1. Okay, so that's what our answer is going to be. 9x squared plus 6x plus 1. And then it says solve fg of x equals gf of x. Now it seems complicated, but it's not complicated at all because you've worked out everything you need for the final question. So fg of x, we've worked out in the first part. It says find fg of x, and we worked out that it was 3x squared plus 1. So we're going to have 3x squared plus 1, and that's equal to gf of x. Gf of x we worked out over here in the second part, and that was 9x squared plus 6x plus 1. So that's equal to 9x squared plus 6x plus 1. Now it says solve. When it says solve, you're going to get everything onto one side and you're going to solve it. You're going to factorize and work out what the values for x is going to be. So do you have to expand the bracket? In this case, you wouldn't have to expand the bracket. The only reason I expanded the bracket is because I needed to expand the bracket for the second part. So you didn't need to specifically expand the bracket for part B, but you would need to expand that bracket for part C to solve it. Okay, so over here, we're going to move everything onto one side. So let's get rid of this 3x squared from this left side and move it to the other side. So at the moment, it's being added on that side. So to get rid of it, we're going to subtract 3x squared from both sides. And that's going to get rid of this 3x squared. So we're going to be left with 1 equals 9x squared minus 3x squared is going to get you 6x squared. And then 6x squared plus 6x plus 1. And then we need to get rid of this 1. At the moment, it's positive on that side. So to get rid of it, we're going to subtract 1 from both sides. So now we're going to be left with 0 on this side. And that's going to be equal to 6x squared plus 6x. Okay. Then when we factorize this, this is a different one to factorize. What you would do is, you know that a rule over here, when you've got ax squared plus bx plus c, if you've got quadratic in this format, you would need double brackets to factorize it. When you've got something in this format, you only need single brackets to factorize it. Okay, so over here, let's pull out a factor which is common in both of them. So we can see a 6 is common in both of them, both of the expressions, and an x is common in both of the expressions as well. Let's open brackets. 6x times what gives you 6x squared? It's x. And then 6x times what gives you 6x? It's just 1. So it's just going to be plus 1. And that's equal to 0. And then if we want to work out what x is going to be, 6x is equal to 0. So that means x is either 0 or x plus 1 equals 0, which means x is equal to minus 1. So those are your two solutions, x equals 0 and x equals minus 1. Okay, so those are your two solutions in this case. That was a single bracket factorization because it was in this format, ax squared plus bx. Okay, if it's in this format, then it would be a double bracket factorization. But because it was in that format, there was no like number left over here. That means you would only use one bracket to factorize it out. Okay. So now what we're going to do is we're going to go back to this question that we looked at. This was inverse functions. So we've looked at composite functions. There's another type of functions that you could be assessed on, and that is inverse functions. And inverse functions are basically functions that have this symbol over here, minus 1. It's to the power of minus 1. So you might have seen trigonometry, inverse sine. So when you click on your calculator, shift sine, it gives you sine to the power of negative 1. Just like that for functions, when you have a function f or g or H or whatever letter, and it's to the power of -1, this means that you have an inverse function. And to work out inverse functions, it's not hard at all. It just requires practice. So we're dealing with the f function, the inverse of the f function. We know the f function is here. F of x equals 2x minus 4. So we know that f of x equals 2x minus 4. Okay, now when we have the inverse function, that just means we need to do the opposite. Okay, we're just going to be doing the opposite when we have the inverse function. This question that we just did over here, this would come up in a non-calculator paper. But if you're sitting sort of GCSEs this year, functions wasn't on the paper. Because it wasn't on the paper, that's why it can come up in a non-calculator or calculator paper. It just depends where the examiners want to put it. For this year's paper, functions wasn't on paper 1, so it can be on paper 2 or paper 3 on a calculator paper. Okay, so we're going to be doing the opposite. And the way to do a question like this, the opposite, all you're going to do is you're going to replace this letter that you have, the x letter, with a y. So you're going to change the x into a y. So we're going to have 2y minus 4. And you're going to make it equal to x. So change x into y. And then what you're going to do is you're going to make it equal to x. That's what you're going to do to work out what the inverse function is going to be. Change the x into a y and then make it equal to x. So 2x minus 4, we changed this x into a y and then we made it equal to x. And now you're going to rearrange to make y the subject. Okay, so we're going to add 4 to both sides to get rid of the minus 4. So add 4 to both sides, that's going to get rid of the minus 4. So you're going to have 2y equals x plus 4. And then you need to get rid of this 2y. At the moment, it's being multiplied by 2. You need to get rid of the 2. So to get rid of that multiplied by 2, you're going to divide by 2. And whatever you do to one side, you do the same to the other side. So you're going to divide this side by 2 as well. That's going to get rid of this 2. So you're left with y on that side, and that's equal to x plus 4 divided by 2. That's your answer, x plus 4 divided by 2. The way that you would write this, you would say the inverse function of x, that's what the question said, that's equal to x plus 4 divided by 2. So that's what you would do for a question like this. When you're working out the inverse function, you're basically working out the opposite. So you're going to change the x into a y, you're going to make it equal to x, and then you're going to rearrange to make y the subject of the formula. Okay, and when you rearrange, you will get this as your final answer. Okay, so moving on. Okay, so we'll have a go at these two examples. We won't have a go at part 3 because that's just a solve equation. We'll have a go at these two examples and then we'll have a look at transforming graphs. So I'll give you guys a couple of minutes to have a go at both of them and then I'll start going through the answers. Okay guys, I'll give you guys one more minute and then I'll start going through the answers. Once you have an answer, type it into the Q&A. Okay, so going through the answers, it says work out an expression for the inverse function of g. When we're working out the inverse function of g, so we know that g of x is equal to x plus 3. That's what the g function is, but we don't want the g function, we want the inverse function because that's to the power of -1. So what we're going to do is we're going to change the x into a y, so we're going to have y plus 3, and then we're going to make it equal to x. And then what we're going to do is we're going to rearrange to make y the subject of the formula. At the moment, we're adding 3 to it, so we're going to subtract 3, we're going to do the opposite of it, and we're going to do the same to both sides. So that's going to get rid of this plus 3. So we're left with just y on this side, and that's equal to x minus 3. So the answer to the first one, the inverse function of g is going to be x minus 3. Okay, the next one, it says work out an expression for the inverse function of f. So the f function, when we look at the question, it says x squared minus 17. So it's equal to x squared minus 17. We don't want the f function, we want the inverse of the f function. So that means what we're going to do is we're going to change this x into a y, and we're going to make it equal to y. So we're going to make it equal to x. So we're going to change that x into a y, so it's going to become y squared minus 17, and then we're going to make it equal to x. And now what we're going to do is we're going to rearrange to get y the subject of the formula. So to get rid of this minus 17, we're going to add 17 to both sides, and that's going to get rid of this minus 17. So we're left with y squared on that side, and that's equal to x plus 17. And then we need to get rid of this squared. At the moment, the y is being squared. We don't want the squared. Okay, we want y standalone by itself. So to get rid of the squared, the opposite of squaring something is square rooting that same thing. So we're going to have y by itself, and to get that, we're going to square root everything on the other side. Okay, so it's a square root of x plus 17. So the inverse function of x, what the question asked us to work out, is going to be equal to the square root of x plus 17. Okay, and that's what your answer there is going to be. Okay, so the final thing that we're going to do before a blockade is transforming graphs. Again, this hasn't come up on this year's paper, and it comes up normally at least once across the 3 papers. So it says the graph of y equals f of x is shown below. So we're given this graph over here. You can see this graph, and we can see a coordinate. The turning point at the tip of the graph is 1, 4. Okay, now really important, the first coordinate is the x coordinate, the second coordinate is the y coordinate. Okay, now it says we've got y equals f of x plus 3. We need to write down the new coordinates. Now, what does this actually mean? There's a key rule that you need to follow for a question like this. If it's inside the brackets, so inside brackets, that means you do as you're told and it affects the x value only. Okay, that's the first rule that you need to know. If the function is inside the brackets, you do as you're told, and it only affects the x value. The other rule is if it's outside the brackets, so outside brackets, you do the opposite. Sorry, I've muddled that up. Inside the brackets, you do the opposite. Ignore that. Don't write that down. Inside the bracket, you do the opposite, and it affects the x value. Okay, and then outside the bracket, you do as you're told, and it affects the y value only. Okay, now what does that actually mean? Okay, so let's have a look at this. So it says y equals f of x plus 3. Is this inside the brackets or is it outside the brackets? We can see that it's inside the bracket. So that means It's inside the bracket, so we're going to do the opposite. So we're not going to add 3, we're going to subtract 3. So we're going to subtract 3, and which coordinate are we going to affect? We're going to affect the x value. So the coordinate that we've been given is 1, 4. That's our coordinate, 1, 4. We're going to affect the x value, so we're going to affect the first value. And we're not going to do as it's told, we're going to do the opposite because it's inside the brackets. Okay, so we're going to subtract 3 from 1. Okay, so 1 is the x value, so we're going to subtract 3 from it. That's going to get you -2, and the y coordinate will stay as it is because we're not doing anything to it. That will stay as 4. So the answer to the first one is going to be -2, 4. Okay, the second example, we've got y equals minus f of x. We can see that the minus is outside the brackets. Okay, so this is outside. If it's outside the brackets, that means that we're going to do as we're told, and we're going to affect the y value. So the coordinate is 1, 4. Nothing's going to happen to the first coordinate. It's going to stay as 1 because nothing's happening to the x. But the outside coordinate, the y coordinate, which is 4, is going to be multiplied by -1 because we're going to do as we're told. So it's going to turn into 1 minus 4. Okay, so that's the answer there. Okay, the next one, we've got y equals f of x minus 3. Because we've got f of x minus 3, we can see that this is outside the bracket. Because it's outside the bracket, it's going to affect the y value, and it's going to do as it's told. So nothing's going to happen to the first value. Nothing's going to happen to the x coordinate, so it's going to stay as 1. But the y value, we're going to subtract 3 from it. Okay, so the y value is 4, so we're going to subtract 3 from it, and that's going to become 1. So the answer is going to be 1, 1. And then for the final example, we've got y equals f of minus x. So this is inside the bracket. Okay, the minus is inside the bracket, it's being multiplied to the x. So because it's inside the bracket, what we're going to do is it's going to affect the x value, and it's going to do the opposite. So it's going to divide by -1. So what's 1 divided by -1? That's going to get you -1, and nothing's going to happen to the y coordinate. So it's going to stay as 4. So -1, 4 is the answer there. Okay, so that's a bit on transforming graphs. That hasn't come up yet on this year's paper.